In example 1a, I've given you a graph. So go ahead and draw that graph on your handout. And the question here is whether or not this graph is representing a one-to-one function. And we're going to use the horizontal line test to determine that. So much like the vertical line test, you draw a lot of different vertical lines and see what happens. Now we're going to draw a whole bunch of horizontal lines and see what happens. So to test if this function is one-to-one, I'm going to come in and draw a whole bunch of horizontal lines. And if I can find even one horizontal line that crosses through this graph more than once, we are not looking at a one-to-one function. So as you look at this horizontal line, we're crossing through twice. That means then that this function is not one-to-one. So you can go ahead and on the handout circle no. And then as you look at B, we can go ahead and try the same process. Draw a whole bunch of horizontal lines. And if you can find even one horizontal line that crosses through this graph more than once, we're not looking at a one-to-one function. Well, this horizontal line crosses through once, this horizontal line crosses through once. I cannot find a horizontal line that crosses through this graph more than once. So this function is one-to-one. And you can circle, yes, this is one-to-one on your handout. So now that we have the idea of the horizontal line test, the problem is, if we look back here at A, this is actually a good friend from earlier in the course. This is the graph of y equals x squared. So if we say that y equals x squared is not one-to-one, we're not going to be able to move forward with him in the rest of this section. And sometimes y equals x squared is a nice friend. We don't want to abandon him. So how could we go ahead and find some way of keeping y equals x squared with us? The answer is we can actually sometimes look at problems and restrict their domains. And if we restrict the domain in just the right way, we can go ahead and create a one-to-one function from a function that is currently not one-to-one. So let's look at this graph of y equals x squared. What I want to do is find a way of looking at only part of this graph. And in particular, I want to make sure that whatever part of the graph that I choose, I'm looking at a graph that will pass the horizontal line test. So if you look at this for a bit and you think about it, there are two reasonable ways of moving forward. So one reasonable way of moving forward is to say that we're only going to focus in on the right-hand half of our parabola. If we ignore the rest of that parabola, then this right-hand half is actually going to pass the horizontal line test. So what we can do is come in and say that x has to be greater than or equal to 0. So what we have just done is restricted the domain. And if we look at the function y equals x squared, where x is greater than or equal to 0, that now is a function that passes the horizontal line test, which means that it would be one-to-one. And then we can move forward with it for the rest of the section. So as you look at some of the problems in this section, you're going to notice that these kinds of statements are running around at the ends of some of these functions. And the reason that those pieces are there, the x greater than something or the x less than something kind of statements, is so that we can restrict the domain and create a one-to-one function from something that wouldn't be one-to-one otherwise.